Hey everybody, this is lesson 7. This is the extension activity called forces and motion. So if you look at your book, and if I slide this over a little bit, you are going to be working on the extension activity 7.1. So go ahead and click on that and go ahead and get started on it. So the learning activity for that is we're going to analyze what forces affect boats. So we're going to start to take what we learned in 7.1, well, what we learned in the entire book, as well as 7.1, and we're going to start to apply it to some scenarios. So here's the background. A sailboat is floating across the lake. 4 forces act on the boat. Its weight, so gravity's pulling it down, the buoyant force, that's the contact force with the water, it's pushing it up, the forward force of the wind, and the backward drag of the water. So you have the wind, it's a sailboat, so you're going to have wind to make it go. Now, notice how it says at a given instant, the force of the wind on the boat and the drag with the water are both equal to 100 newtons. So in this scenario, there's the push of the wind on the sail, which in the boat's connected to the sail, so think of it all as one, and a drag. So when the boat goes through the water, there's some friction there. So that's the drag, that's the backward drag of the water. So at this instant, they're equal. And since the lake is perfectly smooth, the boat moves across the water without bobbing up and down. So there's no up and down motion at all. So go ahead, answer the first question. What is the relationship between the boat's weight and the buoyant force acting on it? So think about the relationship between the 4 forces. If you need to make a drawing to help you out, please do so. Go ahead, pause the video until you're ready to move on to the next question. All right, so here's the next question. Does the sailboat move at a constant horizontal speed? Does it speed up or does it slow down? Explain. So go ahead, pause the video until you're ready for question number 3. All right, question number 3. The wind weakens a bit. So now the wind's not blowing quite so hard. But the sailor on the boat does not want it to move slower. So she turns on an overboard engine to help push the boat forward. What pushes the boat forward, the engine or the water? Explain. So with this one, let's go back to the air-powered car. Remember the car with the fan on top and the flying balloon. So they're all related. So what's going to push the boat forward, the engine or the water? Explain. Go ahead, pause the video and wait until you're ready for the next question. All right, if the force of the wind is now only 25 newtons, what is the force the engine must push on the water to keep the boat moving at the same speed as before? So if you need to back up to take a look at that first background information, you can do that. Or I'll just pop it up right here. So here's the information. So if now the wind drops to only 25 newtons, but the sailor wants the boat to be traveling at the same speed, what is the force the engine must push in the water to keep the boat moving at that same speed? So go ahead, pause the video until you're done. All right, how'd you do? Were you able to answer all the questions? Do you have any questions about this? If not, let's go through and see how you answered. So the relationship between the boat's weight and the buoyant force acting on it have to be equal. Since the boat is not bobbing up and down, it's motionless in the vertical direction. Therefore, all the vertical forces have to be balanced. So that's the boat's weight and that's the buoyant force pushing up on it. They have to be equal. How about question 2? Does the sailboat move at a constant horizontal speed? Does it speed up or does it slow down? Well, since the force of the wind and the drag with the water are equal to each other, there's no unbalanced forces. Therefore, it must move at a constant speed. So how'd you do with that question? That would be like a great test question. I would put it in a different scenario, but having all the background information, you should be able to look at it and say, oh, it's got to be moving at a constant speed because the forces are balanced. And if it's moving, it's got to be moving at a constant speed. It can't be slowing up, it can't be speeding up or slowing down. I suppose I said slowing up. That doesn't make any sense. Third question. The wind weakens a bit, but the sailor in the boat does not want it to move slower. So she turns on an overboard engine to help push the boat forward. What pushes the boat forward, the engine or the water? Explain. Again, the boat cannot push itself forward. It can only push on other things. The engine pushes backwards in the water, but the boat doesn't go backwards. It goes forward. And since forces always come in pairs, the water pushes forward on the engine and the boat. So it's that water pushing forward. It's just like on our car fan. When the fan was blowing, it didn't, the wind was blowing in one direction, but the car went the other direction. It was the wind pushing it. Same concept here. And the last question, if they slow down, well, if they slow down, that engine must push in the water with 75 newtons in order to maintain a constant speed. So if the force of the wind was now only 25 newtons, we'd have to speed up the engine, the overboard engine, and would have to be putting out 25 newtons of force in order to be balanced with that 100 newtons that we learned about before. So again, if you have any questions, please ask. Thanks. Good job.